we are asked to add vectors for this problem. They're giving us a magnitude in this first column spot in the coordinate pair, and in this next coordinate pair spot, they give us the direction of the vector. So it's a vector represented with the magnitude, its length, and its direction given from wherever we're kind of starting on that vector. And then we're asked to solve or find when we add them together. So the trick is when you're adding vectors together that we want to use it in a component form to look at the change in x's, add the change in x's together and the change in y's together separately, and then we can convert it back if we need to. In this case, they just want it in that component form, the change in x and the change in y. So we'll go ahead and take each of these parts and convert it into their components, the changes for the x and y's, and then we'll combine those. Okay, so let's do v first. V is equal to. So the Sanders, I have my side work to help me remember. I don't have these locked down memorized, so I like to think of tangent I use to organize what corresponds with x and y. On my trig functions, tangent helps me with that. I memorize that tangent is sine over cosine. So I have that memorized, and then tangent is like a slope idea. So it's the y over the x for the slope, and then that links together. So sine corresponds with y, cosine corresponds with x. So when I represent the v vector in terms of its components, we're going to do the magnitude of it. The magnitude for v is 7 times its x component, cosine of its direction, 160 degrees. We do the same thing for the y component. Same magnitude for v, and it's a sine that represents the y component. And in this case, the direction is 160 degrees. And this is just typed in on our calculator. I'm going to go ahead and do w also, get that out of the way. And we have the direction for w is 20, but we want to do the magnitude first. The magnitude is 9 times the x component, which is cosine. Have that right there. I can use that same reference. We're using 20 degrees as the direction, and 9 is the magnitude for w, and sine is the y component. The direction is 20 degrees. Okay, so v plus w. Now, actually, I think let's go ahead and write these out so you can see what they are in decimal form. So I'm just going to use my calculator here. Okay, so make sure you're in degrees. We're in degrees here, so I'm in degrees. Check. 7 times cosine of 160 degrees equals negative 6.577 ... I really encourage you to use your calculator along with me. You should be able to type these same things in and match my answers as I go along. Comma, the y component, 7 sine 160 equals 2.394 ... There's the decimal representations for those. 9 cosine of 20 is equal to 8.457 ... And 9 sine of 20 is equal 3.078. Now, one of the things that was in the original problem here is that it said that we could round and into the hundredths place as we do these. But for me, I really like pushing myself to try to round only in the answer, which is what's proper in math. So they're kind of giving you an easy out by being able to round during your math, but be very careful about that. Just sort of know that's kind of an exception of what is usually required. So what I'm going to do is I calculate these again, and so on my calculator, what I'll do is I'll calculate 7 cosine of 160. I'll get that answer. This calculator can only store one thing at a time. So I'll keep that answer, and then I'll say plus, and it gives me that answer, and then I'll type in 9 cosine of 20. And then I'll actually get the actual answer here, which is what I was trying to say is important to do. So V has to come first on this one. keep our format here, and let's see how it does. So, got a phone call, but I want to take care of this first. All right, so I'm going to type in 7 cosine 160 equals, okay, so I get that answer right here, plus 9 cosine of 20. Okay, so I got 1.879 ... And the next one is 7 sine 160 equals, so I get that answer. It's this one right here, the infinite decimal, plus, so I stored it, plus, then it's the 9 sine of 20 equals. And I got 5.4723 ... And now I can round. So this is approximately equal to 1 point, I'm rounding to the hundredths place. That's this one right here, so I look at that number, 1.88, and comma, hundredths place is this one right here. I look at that one, 5.47. Okay, so it's kind of nice to kind of get a visual representation of what this looks like. So the visual representation, so I'm going to look at this one first. The graphical representation is, I got 160 degrees. So this is 180 degrees, this is 90 degrees, so it's like kind of right here, and it's a distance of 7 right there. So I got 160 degrees, and that's a distance of 7, and then I add to it and I like to look at it in the direction first. So it's kind of like you're starting all over again. That's the thing about vectors, is you're starting all over again. That's like a new axis or new coordinate system. 20 degrees is real close to 0, so it's like going in that direction, like that. And I'm going longer than 7, so I'm going about 9, and I would assume it's about right there. Okay, so question is, does that make sense with this component vector of them being added? Okay, so let's check out what this one looks like. So this one would be an x, a change in x, and a change in y on this. So a change in x is almost 2, so it's like 1, 2 for my x change. My change in y is like almost a 6. 1, 2, 3, 4, 5. Yeah. So it's about in that region right there. So if I had just notice it kind of links together. It doesn't have to be perfect. We're just kind of doing a guesstimate. Does that make sense with those two? And yes, it does.